I'm going to go through the steps of solving a kinematic equation. This problem is from the assignment classwork examples that you'll have to work through this week. So let's just start. A person traveling downwards in a hot air balloon at a constant velocity. So step one of solving a problem is to draw a picture. All right, so here's my hot air balloon, and it looks like this. You don't have to be a great artist. The person is traveling downward in the hot air balloon. So there's the hot air balloon, here's the ground, here's the person. So this hot air balloon is traveling downwards at a constant velocity of 8 meters per second. And he accidentally drops a sandbag. So here's the sandbag that he's going to drop. Okay. Now that we've drawn the picture, we need to make a coordinate system. So determine which way is positive and which way is negative. So I'm going to say that up is positive and down is negative. Once we've done that, we can then decide that this speed, because it's traveling down, this sandbag will have a speed of negative 8 meters per second, or a velocity of negative 8 meters per second. All right, and so then we're going to, what do we know? And what are we looking for? Okay, so I always start by writing all of my variables, my initial position, my final position, my initial velocity, my final velocity, my acceleration, and my time. So highlighting the problem is always a good thing. Constant velocity of 8 meters per second, but that's going to be downward. And so that's going to be my initial velocity is negative 8 meters per second. Notice how I put a number on this. My final velocity, well, we don't know. We don't know. A person is traveling downward. He accidentally drops a sandbag off the balloon. It doesn't say anything about the position that he starts with. But if up is positive, I'm going to make this ground at 0 meters. And so my final position, when that sandbag finally hits the ground, 12 seconds later, it will be at a position of 0 meters. Okay, 12 seconds here, and I'm going to highlight that. We know that, 12 seconds. How high was the balloon? So what are we looking for? We're looking for the initial position. How high? That's what we're looking for. All right, and the last thing is what's the acceleration of this object? Well, it's going to be the acceleration due to gravity, which is the opposite of the gravitational field strength, which is negative 10 meters per second squared. From here, all you have to do is figure out which equation you want to use. So I'm going to write them down. Velocity is velocity initial plus acceleration times time. Change in position is the initial velocity times the time plus 1/2 acceleration times squared. And then we get velocity final squared is velocity initial squared plus 2a delta x. From here, we get to pick which equations make sense and which equations don't. So if I am looking for position, but I don't know the final velocity, which equation do I want to use? Well, obviously not this one because it has the final velocity in it. So we're not going to use this guy. And this equation, or equation number 1, doesn't even have position in it. So we're not going to do that. So we're going to pick our equation to be this. This is probably my favorite equation of the kinematics. So we're going to use this equation, and then we're just going to plug in the numbers that we know. Remember again, delta x is just x final minus x initial. And so if the final position is 0, then this is going to be negative the initial position. So once we write down what we know, what we're looking for, 4, we pick an equation. And then 5, you solve. At this point, I really don't care about your math skills, so all I want you to do is figure out your equation. Please feel free to plug in the numbers if you want to, but once you pick your equation, the next step, just plug them in, but don't do any algebra. So we'll say negative of the initial position is going to equal our initial velocity, so negative 8 meters per second, times our time of 12 seconds. Oops, that looks like 12 seconds, plus 1/2 times negative 10 meters per second squared times 12 seconds squared. Sort of ran out of room. Super important that you put your labels, your units in your equation as you're going. All right, that's it. I hope you guys will hit me up if you have questions.